Our society is in need of raw materials, and we know that at this point recycling is simply not sufficient. We can look for deposits on land, but there's also a vast amount of deposits available in the deep sea. And that's where our research comes into play. We investigate whether deep sea mining can be a viable industry with an acceptable impact. There are three main deposits in the deep sea. Those are polymetallic nodules, seafloor massive sulfides and cobalt-rich crusts. In blue harvesting we focus purely on polymetallic nodules, and those nodules are distributed on the abyssal plains of the seabed. That's typically at 4 to 6 kilometers water depth. And for deep sea mining, there we focus on how we can extract those materials, and at the same time also thinking about how can we do that with the least environmental impact.
The environmental impact of deep sea mining is a very major concern.
The mining vehicle, it collects nodules along with unwanted sediments and water, which needs to be discharged from the rear of the mining vehicle. So this sediments, which is being discharged, it has the potential to harm benthic organisms, benthic life that is present.
The goal of the project was to develop a hydraulic collector which emits a lot less plume from the backside of the collector, and therefore we wanted to develop a second generation collector which is a lot more environmental friendly.
My goal in the research is to understand the physics and the mechanics of the flow directly behind the collector, which we call it the near field region. Understanding the physics meaning not only the dynamics of the particles, but also in a way to understand how particles behave with each other, like for instance flocculation.
So flocculation is basically the particles coming together, sticking together due to the presence of organic matter and settling, and thus reducing considerably the spread of the plume.
The main thing regarding Apollo is design the discharge itself, finding the favorable discharge condition at the discharge in order to enhance, for instance, flocculation. The discharge conditions are represented in the concentration for discharge velocity and also, for instance, for the height of the discharge itself.
We first did lab tests with the collector, and then we want to achieve field results with the see how it would operationally and technically and environmentally perform in the field.
So in this project what we try to do is collect field data about this behavior of this plume. For one part we want to know how this plume evolves, and that this data can be used in predictive models, so that before an operation starts that we can already predict in advance where do we expect this plume to spread and where do we expect this impact.
So during the field test we deployed this kind of platforms equipped with different sensors to record the suspended sediment dynamics, and it measures the suspended sediment concentration along with the current at one specific point.
So we developed the model. We solved the model for the area almost 120 meters behind the collector. The model will be open source soon.
After finishing the design, we wanted to test the functionality of this collector. So I have conducted, along with my colleagues, full-scale experiments where we tested different operational conditions to actually know the pickup efficiency of this collector.
From the start, we had very good performance of all the equipment on board. We hardly had any delays in performance. Only one thing was not good. We didn't have enough power in our electric motors. We had a couple of days, and in those 3 days we exchanged all the electric motors.
The results of our experiments were actually very satisfactory, because we had even managed to fulfill a pickup efficiency of 100%.
We managed to pick up so many stones that all these casings here were completely full with nodules, which meant that we were almost too heavy to get ourselves back on board. From then it was a smooth ride, 5 days of driving. Now it's up to the environmental measurements and analysis of those measurements, how these different drives were performing and what settings we can use for the future.